Okay, so let's do some work. Now, I have in front of me the test, and I made part 1 earlier, and you can look at that. It's on the chem site. Let's see. You have to be able to name acids. What's your acid nomenclature? Do you remember? What is ternary acids? Ternary acids. Or oxyacids. Ternary acid is a hydrogen plus a polyatomic ion. Correct? It has no prefix. It's the root and then ik for 8 and us for eit. Correct? What is a binary acid? Binary acid, for instance, iodide. What does that mean? Binary acid is iodide. What are you saying to me? Iodide. You're just saying the word iodide. It's like, is that code or something? Or?
It's a fun word.
What is it?
It's a fun word to say.
Muhammad's whispering. He doesn't want to be heard.
It's a fun word to say, Mr. Darcy.
It's a fun word to say, iodide. Excellent. I'm glad you're enjoying yourself. Excellent. Anything to entertain you? Yes, Jen?
So binary acid would be like hydrosulfuric acid?
Yes, hydrosulfuric acid, for instance. Binary means that it's hydrogen plus a what? A non-metal. Non-metal, right? Such as iodine, the iodide ion, chloride ion, bromide ion, sulfide ion, etc. For instance, hydrosulfuric acid. So you use hydro, then the root, then ik. Hydrosulfuric, hydrochloric, hydronitric. Clear? Yes? Okay. The next thing that you're going to have to do, could you give me some paper towels over there, Mohammed, please? Thank you. Yes, somebody had a question. Mohammed, you have a question?
Hydro has to be in front of...
Hydro is a prefix that must precede the root of any binary acid name. Okay? Of any binary acid name. All right, what's next? Let's see. I'm just going page by page here. On that review, part 1, I did some things on empirical formula, percent composition. For instance, let me ask you this. Let's see. Let me ask you this. What has a higher percentage of gold? What substance? Gold 3-chloride, gold 3-chloride, or gold, what? Let's see, gold oxide. What has a higher percentage of gold? Gold oxide has a higher percentage of gold? That's kind of an easy one. Let's not take this one. Let's do another one. Let's say gold 3-chloride or gold nitrite, gold 1 nitrite. All right, let's do percent compositions. We have two of them to do. Let's put them next to each other. So gold 1, obviously they may not even exist, right? Gold, what? Gold nitrite, gold 1 nitrite, gold 3-chloride. Okay, what is the atomic mass? What's the mass number? Let's do mass numbers. What's the mass number for gold?
108.
Okay. The mass number. Do you remember what that is, Mohammed? Mister, I'm doing more homework this year. I heard you say that.
79.
What is it?
79.
79 is the mass number, or is that the atomic number?
I'm sorry.
That's okay. Jen?
108.
108, is that correct? I don't think it's how'd you get 108? How'd you get 108, Jen?
No, I was looking at silver, sorry.
197.
What is it?
197.
197. Okay, so there's one of each here. So this one is going to be, what did you say, 197?
Yep.
197 plus 35 times 3, which is 105. Is that right? And what's that? So it's going to be 12, 0.
200. 202.
302, correct? And then 197, isn't that the total gold? 302, what's the percentage of gold in that then? What is 197 divided by 302? Jen?
65.23%.
65, can we say 65, is that okay?
Yeah.
65%? Somehow I don't think it's going to be that close, do you? Okay, so this is going to be, there's only one gold there, so 197 plus 14 plus 32 is going to be what?
81%.
81%.
No,
You
no,
did
no.
you did it already?
Yeah.
Okay, so let's slow this down a little bit so everybody can have fun here. 3, 10, 4, 2. Is that correct? 243? Is that correct? Okay. So 197 divided by 243 equals times 100 times 100 is going to equal what?
81.
81%. So that's something you're going to have to do. You're going to have to compare two compounds, two substances, and you're going to have to, you can either do it intuitively, like Jen did, and say, well, hey, you know, this is only 14 plus 32, that's only 44, right? 44, and that's like over 100, so this would have a lot greater percentage of gold than this, correct? By weight. Yeah. Okay, so what's left? What's next? You have to know, we did a problem this morning where you have to know moles, mass, etc., volume. Yes? Let's continue. Let's see. All right. All right, how about this? I'm going to have 400 grams of gold. We're picking on gold today. I can hear gold now. No, you're picking on me. No. He's so mean. All right, so I have 400 grams of gold. I want to know two things. How many moles of gold are there? And how many particles of gold are there? How many gold atoms? Okay? How many gold atoms? Okay? So what would I do to that to get the number of moles? Well, I could use a proportional relationship. Go ahead, Bounce. You're like, you know what's going on. You've already figured the problem out. You have that. I'm done. I'm finished. I'm not even thinking anymore because I did all this in my head mentally in the last 15 seconds. Go ahead. Give us the sum of your knowledge about this. Go ahead. Well, what would I divide that by?
197.
Yeah, 197. Why am I doing this so quickly? Well, I know that 1 mole is 197 grams. I just did that problem, right? So how many 197s are in 400, right? So it's going to be 2 point something?
2.02.
What is it?
2.03.
2.03. So it's going to be 2.03 moles. And then how many particles is that? Approximately,
1.22 times 10 to the 20.
well, it'll be 12.04, 12.22 you said?
Well, then it would be 12. Yeah, 12.
What is 2.03 times 6.02?
12.22.
12.22 times 10 to the 23rd atoms of gold, or if you want to go completely crazy, you could say 1.222 times 10 to the 24th atoms of gold. Yes? Questions about that? Are we okay with that? Musaba, how you doing back there? You all right? Ooh, he's giving the thumbs up. I like that. Great, shows great confidence. Excellent. All right, what's next? What's next in our review? What's next? Let's see. So, are you pretty good with moles and mass and particles? Kinga, how you doing with that stuff? Okay, you all right? Pretty all right? Okay. Let's see. All right. Let's do something we really haven't talked about, but I'm kind of putting the test off because of this. Okay? Yes? What is the density of chlorine gas? What's the density of chlorine gas? Could you figure that out just by saying that? What's the density of chlorine gas? Jen's shaking her head. No. Can't do it. Nope. It's actually quite easy though, isn't it? All right, now let me tell you this. I want it in grams per liter. Whoa. No, you know what? I want it in grams per liter and grams per milliliter. I want it in both. Okay? Yes? How would I do that? How would I come up with the density? What two things do you need density? What do you need?
Mass and volume.
Isn't it mass over volume? Right? Don't I know the volume of anything relative to that gas? What do I know? I know the volume of a mole, right? Right? So don't I say 1 mole of chlorine gas is 22.4 liters? Can I say that? Yes or no? Now, just guessing here, don't you know, I mean, you need grams here, right? Don't you know what the mass is of 1 mole, Miss Genevieve? Miss not bright enough to do this? Is that true? Is that a true statement? I think that's a nonsensical statement. I think, but Mrs. Jennifer, she shook her head. I said, "Can you do it?" She said, no. She was very emphatic that she couldn't do this. But if you think about it now, Jen, can you do it? Absolutely. She's very. It's a confidence. I like that. So what would you say there? What's the mass in grams of a mole of chlorine gas? 70, right? I mean, we're rounding, a little round off error there. Is that okay? Are we all right? Okay. So it would be 70 grams per 22.4 liters. All right. What would that be, therefore, in grams per liter? Grams per liter. What would that be? What would it?
3.125.
All right, sorry?
3.125.
3.125? Can we just say 3.1? Is that okay? Is that all right? 3.1 grams per liter. Is that okay? All right. So what about, let's convert that to milliliters per gram. Yeah? 3.1, what does that say? 3.1 grams? 3.1 grams per what? Per liter. So what would that be? What would that be? I want to convert that to per milliliter. So what would I multiply by? Liter over mils, right? Liter over mil. 1 liter, 10 to the third. So it's going to be 3.1 times 10 to the negative. You can do it. -3 grams per milliliter, right? Yes? Yes? What is air mostly? What is it mostly? It's nitrogen, good. So what's the density of air if it's just mostly nitrogen? About. So I know it's got oxygen in the air and a little argon too, I understand. But let's just pretend let's just pretend it's all nitrogen. Let's just pretend, right? It'll be a little bit more dense than this, but let's pretend, okay? So what would the density of air be if it were all nitrogen? And I want this in grams per milliliter. Now let's just do grams per liter. That's cool. We're cool with that.
1.25 grams.
So it would be 28, right, per 22.4 liters. Is that right? And it would be what? 1.25 grams per liter, right? What's the density of carbon dioxide? CO2. What is it?
1.96 grams per liter.
So you see that the carbon dioxide is actually significantly denser, isn't it? I think that's significant, don't you? Yeah, a long time ago, I don't know if I told you about this, but there was a village in Africa. I think it might have been Cameroon. I don't remember where. I don't look this up. Village in Africa smothered by carbon dioxide. Village in Africa smothered by carbon dioxide. Very sad event. Very sad. Can you imagine? You know, going for a trip, you know, leaving your folks at home, and all of a sudden you go there and everybody died. Well, this is what happened. Here is a mountain.
Yeah, Cameroon.
It was in Cameroon, and this is a volcano. This is a lake. Okay, I guess the lake is like there. Okay, there's a volcano, an old volcano, and in the volcano there's water. It's a lake, right? And the lake is very deep. And then one evening, the lake literally burped up enormous quantities of carbon dioxide that were trapped underneath the water, under tons and tons of water. Okay? And the carbon dioxide came out, displaced the oxygen, and the village was here in this depression, and all the villagers died because carbon dioxide is much denser than air. Amazing, isn't it? Sad, terrible, terribly sad. How many people died in that, does it say?
1,700.
What did you say?
1,700.
1,700 people died overnight.
And it was about 100,000 to 300,000 tons of CO2.
All right, let's put that on the board. Okay, wait a second. Let's put that on the board.
2 people survived.
All right, so out of this lake in Africa, in Cameroon, you know where Cameroon is? It's like West Central Africa,
Below Nigeria,
below Nigeria,
next to Central Africa.
next to Central African Republic. A lot of problems in Central African Republic today. A lot of stuff going on. So how much was it?
100,000 to 300,000. So
100,000
tons.
to 300,000 tons.
Yes.
You wrote 30,000.
What is it?
You wrote 30,000.
100,000 to 300,000 tons. That's a lot. That's a lot. A lot, a lot, a lot. Can you imagine?
How many liters is that?
Well, let's see. How many liters is that? All right, well, let's see. How many liters is that? Well, let's see. That says tons, right? So let's use the bigger one, okay? And the question is how many liters is that? Well, let's see. Well, so you have 300,000 tons, right? Right? How many pounds is that? We got to use pounds. I apologize. We're using pounds. How many pounds is a ton?
About 2.
So let's convert it to liters, okay? This is carbon dioxide, okay. So 300,000 tons. Let's go from tons to pounds. 1 ton, 2,000 pounds, correct? Let's convert it from pounds to kilograms. Is that okay? Pounds to kilograms? Yeah? All right. So pounds, do we want to go to grams or kilograms? We'll go to kilograms. Is that okay?
Well, 1 pound is 450.
Well, 1 pound is how many kilograms? Oh, sorry. 2.2 pounds is 1 kilogram. Right? Right? Yes? And let's go from kilograms to grams. Is that all right? 1 kilogram, 1,000 grams. Correct? Yes? Are we all right with that? Now, we want to convert from grams to liters, right? How many grams in a liter of carbon dioxide? You have the density. That's the density. That's the reciprocal of the density. What was it? 2.0, what was it? What was the density of carbon dioxide that we came up with per liter? What was it? What is 44 divided by 22.4?
1.96.
What is it?
1.96.
1.96. So it was 1.96 grams per 1 liter, right? So let's do that. 300,000, write this down, calculate this out, get your calculator. 300,000 times 2,000, right? Divided by 2.2 times 1,000 divided by 1.96 equals. What do you got?
1.39 times 10 to the 11.
All right, so let's write this down, okay? Let's write this down. Do we have any verification on that, on what Professor Slezak said? Do we have any verification on that? What'd you say, Mark?
1.39 times 10 to the 11.
Times 10 to the 11th liters? Is that what you said?
Yes, sir.
Correct? Yes? Yes?
By the way, 1 ton is 2,200 pounds.
Okay, yeah, 1 ton is 2,000 pounds. 1 metric ton is 2,200 pounds. But you didn't say metric ton, you said ton. Okay? Now, how many cubic meters is that? You see, density, you will find out when you take physics, is in cubic meters. It's kilograms per cubic meter. That's what it is. So how can you convert liters to cubic meters? Liters to cubic meters. Liters to cubic meters. Well, I don't know how to do it. This is what I'm going to do. We're going to do it the Darcy way. How many milliliters are there in a liter? 1,000, right? Right? 10 to the third, right? Now, milliliters to cubic centimeters, isn't it 1 to 1? Isn't it? Correct? Now go from cubic centimeters to cubic meters. Right? How many cubic centimeters are there in a cubic meter?
100,000.
How many centimeters are there in a meter? How many centimeters are there in a meter? 100, 10 squared, right? Cubit. What happens when you cube 10 squared?
10,000.
No. 10 squared? 10 to the 6th, right? A million. Right? Right? Right?
Yeah.
All right, so put that in. Put in. Now make sure you can do it on your calculator. You guys were wrong once upon a time. So put in 1.39 blue, second function, comma, the EE, and then put in 11 times 1,000 divided by 1 million. What do you got? Are you guys doing this right? I would hate this to go internationally and you guys have no idea what you're doing. We need a verification too. We can't just... Masa, do you have it? What do you got?
0.001.
There's no way. I mean no disrespect. You're a wonderful person. But I don't think so. Could I borrow somebody's Texas Instrument? Jen, may I borrow yours? May I? Excuse me. All right. So let's. You know what? I want to go back and check the original that Mark got. What was the calculation? I don't have it there. Did you write it down? Remember, 300,000 tons. Wasn't it 300?
300,000 times.
300. Wait a second. Hold it. I can do this. Wait a second. Wait a second. 300,000
Times 2,000.
Wait a second. Hold it. 300,000 times 2,000. Go ahead.
Divided by...
No, was it times or divided by? Did anybody write it down? Divided by 2.2?
Yeah.
2.2, and then what?
Time. And then there was multiplied.
Not 2.2, 1.9.
No, that was later on. Divided by 2.2, so that brings it into pounds, right? Now I want to go from pounds, so that brings it into kilograms, right? And then I want to go from kilograms to grams
Multiplied by 1,000.
times 1,000. And then what? So that gives it grams, right? Then it was liters over grams. And then it would be divided by 1.97. Okay, I get 1.3839, close enough, times 10 to the 11th. Okay, that was correct then. Okay, so 1.38 EE 11 times 1,000 divided by 1,000,000 equals, a lot, equals 138. I don't know if there's a comma there or not. Let's see how many zeros are here. Goes 1, 2, 3, 4, 5, 6 zeros. That's an enormous amount, right? Right? Can you imagine? So that is that right? That's 138 million cubic meters of gas. It's a lot. This is 1 cubic meter. Right? Yes? A lot of gas. Okay. All right. Enough of that. That was a nice little practice on changing unit labels, analyzing dimensions. That was good. That was good. All right, now, what's next? We did take care. We did, let's do an empirical formula, shall we? Shall we do an empirical formula? I did one before on the test. All right? All right, let's see. Let's see. Let's say, you know what, let's do our own. Let's pick a problem. Calcium bromide. Let's do the percent composition of calcium bromide. Okay? What is the percent composition of calcium and bromine? Okay? So what's calcium? 40, right?
Yes.
Plus 80. Plus 80. Isn't bromine 80? Is bromine 80?
Yes.
Yeah.
80.
Okay, so what does that equal?
120.
What is it? 0?
200.
200. So what is going to be 40 divided by 200, that'll be the calcium, and 160 divided by 200, that'll be the bromine. So this is going to be 20%, and this will be 80%. Correct? Yes? Now let's say you're given a substance that is 20% calcium and 80% bromine. Correct? Easy? What's the empirical formula? So now we're going to work backwards. So we're going to assume that that's going to be based on 100 grams. So that'll be 20 grams and 80 grams. So how many moles of calcium are there?
Half a mole.
20 grams divided by 40 equals 0.5 moles. And how about bromine? 80 grams divided by 80. That's how many, that's the mass, the molar weight of 1 mole of bromine. That equals 1 mole. What's larger, the moles of bromine or the moles of calcium? Simon, you okay back there? You all right? Okay. So it would be bromine, 1 mole, over calcium, which is 0.5 moles. So it's going to be calcium, it's going to be bromine over calcium, 2 to 1, which is what we started with. So you can do any complicated problem you want. You just start with the formula, you do the percent compositions, then you work backwards. Come on? Are you having a bad day? Okay. All right. What do you think? You guys have had it for the day? All right, shall we quit? Is that okay? And that'll give you a chance to, do some work, do some studying. You kind of figure out what's on the test little by little. Now, what's today? Today is what? Today's Sunday. Tuesday, you have a quiz on 3 quizzes. Equation writing. What does that say? Moles, mass, and volume. And then empirical formula and percent composition. Are we all right with that? You see that? Okay. And then we'll maybe do another review. Yeah? Okay. All right? Good. We're off.